Discord at all. So if you weren't here last week, you should still be able to follow along perfectly fine. Okay. So yeah, so if you weren't here or you don't know about that, that's not really important. We're going to just teach you some new features in Python that weren't covered in the beginner, I guess, Python lessons that I did at the beginning of the year, and we wouldn't expect most of the people that were in advance to know them either, because they're not even taught in the in Mr. Kwan's grade 10, 11, or 12 courses, right?
Yeah, exactly.
So yeah. Oh, you made 3 separate files. Okay.
I'm gonna share my screen now. Hopefully everyone can see this. It's gonna be. We're gonna do all our lesson in code today. We're not gonna have any slideshow, so it's gonna be more of like a live example.
Right. Right. No slideshows. Okay, so we're gonna get started with asynchronous programming. Okay, now this is not to be confused for those of you who are familiar. This is not to be confused with multi-threading or multiprocessing or anything like this. Okay, we're not going to. The idea behind asynchronous programming is to give the computer no downtime. Okay, absolutely no time to relax. This computer is made to work, and so we're going to put it to work at all available moments in time. What do I mean by that, right? Say, for example, that you have a program, right, which does a lot of stuff, but kind of before you get into that, you need the user to enter something, right? You need the user to maybe enter, some like number or some string or whatever, and then your program will take that and do a bunch of stuff with it, right? But maybe but the thing is, the user is going to probably take like a significant amount of time, right, to be typing that in. And at that point, the computer is not doing anything. It's just waiting for the user, right? With typical Python code, whenever you have the input function, the computer's just going to sit and wait and kind of twiddle its thumbs and wait for you to enter something, and then it'll proceed very quickly from there. What we want to do by using asynchronous programming is to have the computer be doing something, okay, while it's waiting to do something else. All right. So while it's waiting for you to type something in, it will be carrying on with another part of the program, and then at certain points in time, it will kind of check back in to say, oh, has he entered yet? No. Okay. Has he entered yet? No. Okay. So it's going to kind of have that sort of, I guess, flow.
Okay. So maybe like you're confused by what Max is saying. What do we mean by that, right? So say, for example, right, we have, let's just create a function, right? I'm going to call it f. It's going to, oh, no need to import anything yet. And what it's going to do, well, actually, we're going to import time for this example, right? But say we have a function, right? The function starts running some code. And then maybe it's doing something like fetching something off of a website. That often takes time. So we're just going to simulate that using time.sleep, okay? And that's going to sleep for 1 second, say, right? And then end a function, right? And I'm going to write start a function, actually. Start of function. Okay? Right? If we then want to run this code twice, right, what's going to happen, right, is, as you would expect, right, we're going to go into f, we're going to print start a function, we're going to wait for 1 second, print end a function, exit that function, and then we're going to enter the function a second time, and we call it a second time, and then print start a function, sleep a second, and then end a function, right? And so I'm going to run that. You're going to see that exact same thing. So I had to kind of grow it in size, but I'll run it again, right? Start a function, we wait a second, and then everything continues. But the idea of doing this asynchronously, right, is that this downtime does not matter, right? What we want to avoid is preventing other code that we could be running from running during this point of downtime, right? So if you imagine, right, I have a Discord bot, right? That's what we were working on last time. Say that Discord bot has been tasked with sending out, I don't know, 100 messages, right? Now imagine that bot has slow internet for the sake of exaggeration, right? Pretend each message takes like half a second to send, right? If it needs to send those 100 messages, it's going to take 50 seconds, right? Because it's constantly waiting for that message to get sent out before it continues with its code, right? So what we're going to let it do, right, is do it in a smarter way where we don't wait for that message to send, okay? Right?
Right. Exactly. And I'm just going to make a quick note. If you're the kind of person that usually follows along during the meeting, I would recommend probably you don't have to do it this time. It's more important that you just really make sure you understand because we're not going to end up with any sort of like final project like by the end of today, right? So next time we'll be using all of these concepts, and at that point it would be better to follow along. But here, just make sure you can still follow along if you want, but just really make sure that you're really paying attention. You know it, like you understand what's going on.
Yeah.
So.
And I'll make sure to upload this one as a video so that you guys can look back on it if you're confused.
Mm-hmm. Right. Okay. So now that we've got this, let's, I guess, create our first asynchronous function, right? So an asynchronous function being a function that where we can, do things which are or is a function which it can be non-blocking. So time.sleep is an example of what's called a blocking function because it basically blocks your computer from doing everything else. So most functions are blocking, but async functions are non-blocking. And so let's see how to do that. So what we can actually do is make a normal function. And what should I call it?
So what is this function for? Sorry.
I don't know. This is going to be an asynchronous function. I'm going to make it asynchronous in a second here.
Call it G. It's fine.
G. Okay. So we'll make a function called G, and actually in this one, and what should I do? I forget what the example that we came up with, like it did.
It was foo or something, right? And then it's
Yeah. But what did it do though?
It just said foo is running. It slept for 2 seconds and then it.
Oh, I see. Okay. So what we'll do, yeah.
So basically,
we'll print.
Right.
Yes.
Yeah, except the sleep is async.
Yeah.
Yes, exactly. So what we'll do is we'll print out G is running, and then what we'll do is we'll do another sleep, and we'll make this one for 2 seconds. Okay. And now I want this one to, and in fact, we're going to do this for both of the functions. What I can do is I can type async, okay, in front. And that will convert these functions into what are called coroutines, okay? And coroutines can be kind of swapped between, whereas functions cannot, right? And what I'll actually do, you know what, I'll get rid of G. I want to illustrate this point. So if I just have the normal function f, right, and then I go print f. So I'm not returning anything. I'm just printing the actual object here. If Alex runs this, you can see what happens is, everyone can see that, right? Yeah. It says there's function f, okay? So that's what we're printing out. It's a function object, okay? However, if we make this, yes, exactly. If we make this async, okay? And then we print f, and then we actually call it here. This is not calling it. This is just returning the coroutine. This is how you return a coroutine. And we'll see it's no longer an object. It is instead now a coroutine object. Okay, yep. So this is an asynchronous function, is what you can also call it. All right, cool. Now, how do we run it? Okay, we obviously, let's try the obvious thing. Let's just do this, right? And I can get rid of this now.
Right, so we run it, and what we get is it's saying, warning, coroutine was never awaited, and nothing ever happened. We never actually saw this start of function and
Wait, what did you do with the G root?
I got rid of it.
Oh,
Sorry.
okay.
It's just sorry. I got a little bit ahead of myself. I just wanted to make this point here. We didn't need G for that. So that's not how you actually call or start a coroutine. Okay. The way we actually do that is by importing a module. Now you don't have to install anything. This comes with the Python standard library, so it's just like time or like math. So it's called async IO. So we just write import async IO. Okay. And then what we can do is we'll take this coroutine object, right, and we'll pass it into async IO.run.
didn't mute your microphone, by the way.
Oh, me, sorry.
There we go. And this is how we'll actually get started running the coroutine. So F is a coroutine, and then async IO.run is just going to run the coroutine. So now we'll actually have the exact same, I think, output as we did at the beginning, right?
Yep.
Okay, cool.
So it prints start a function, waits a second, and then prints end a function. You can kind of see that delay if I run it again, right? There's like a 1 second delay before the next message prints.
Okay. Okay, so now what I'll do is I'll make another asynchronous function. And this will be G. Okay, and I'll print here G is running. And here I'll sleep for 2 seconds. So this is going to, and I actually have to do async IO.sleep, right?
Yep.
So we want a version of sleep which is non-blocking. So like I said, sleep is a blocking function. It's not a coroutine. It's just a regular Python function, which means it will just completely block our computer no matter what. That's not what we want. So we'll use a different version, which is just async IO.sleep. It'll do the exact same thing, except it'll run it as a asynchronous function, and therefore we can potentially do other things, right, while async IO.sleep is taking its time, right? So you imagine, right, what's going to happen when we do this async IO.sleep is the computer is going to, well, actually, we want to signal to the computer, right, when we say async IO.sleep that, hey, we're not doing anything now, right? Like, there's the possibility that we're actually, you know, this is some downtime in which we can do something else, right? Because we're just sleeping. So what we'll do is we'll use, did that? Sorry, on my end. Okay, on my end, the syntax highlighting is weird.
It's all good, don't worry.
Yeah.
So, yeah, with this await keyword, basically what's happening, right, is that it tells the computer, right, while this function runs, feel free to jump to some other part in the code. When this function is done running, put me back here, right? So you can imagine when we're working with the Discord library, for example, we're going to like send a message, right? And that might take some time before we can continue, right? And so while we're waiting for that message to send, we can do something else.
Right, exactly. So now what we can do is in here, I guess instead of, well, let's just we'll get rid of the sleep temporarily, okay? Or actually, we'll just completely get rid of it, okay? The syntax highlighting is so weird. It's like not doing the commenting or anything. Syntax highlighting. So, but okay. Anyway, what we want to do is we want to call G, okay, in F over here, right? So we can write, I think we can just write await G. Okay.
Yes.
Now, okay, and this will be fine. This works because we're inside of an asynchronous space, so we can, instead of doing this whole async IO.run, we can just say await G, and basically what it'll do is it'll switch back, or it'll go to G, and then, well, I guess you can kind of see what happens, right? So yeah. So what'll happen is F will start running, right? We'll print start a function. Then we'll go into G. Okay, we'll print G is running. We'll await a 2-second sleep. Okay, and then we'll print end of function. And I believe I said that correctly.
Right.
Right. So this basically runs more or less how you'd expect it to run.
Right. This would basically be the exact same thing if we removed a so as of what we have so far, right? This is actually basically going to produce an equivalent result to if none of these were marked as asynchronous functions, we didn't await, and we used time.sleep, and we just called f, right? Because we only have one of these instances running, right? It's going to have to wait for this 2-second timer to run off before we can print end of function, right? So we're going to see start a function immediately followed by g's running, and then waiting 2 seconds before end of function, right?
Mhm.
But the magic's going to happen when we start calling this thing multiple times, right?
Right, exactly. Yeah, right, exactly. So right now, if we call it multiple times, we still have to introduce some stuff, right? Because if we were to just say await G again,
No,
okay,
that's
that's
not
not
what I
going to
mean.
do
That's
anything.
not what I'm saying. You're right.
Right. So what we have to do is, I believe, make it into a task. So I'm actually wait. Sorry, Alex, can you take over for a second? So I'm forgetting exactly how to do this.
Sure. Okay. So what we can do, so should I call f multiple times or g multiple times?
G multiple times, that's what I was
All
thinking.
right. So what we can do, right, is async IO dot, and it is create task.
Is it make? Or is it make
right?
task? Create task, yeah.
Or are you looking for the one where we pass in multiple functions?
No, that's not what I was looking for.
So async IO
Yeah.
dot create task, and then inside here you pass in g.
Yep. Yeah, like that, right? So this will, and we can actually assign this. So task equals. Okay, so this is basically creating a task. So a task is basically just an instance of a coroutine, right? And what this is going to do is it's going to start up G, okay? But we're not going to wait for it, okay? So before we were saying await G, okay? And that was kind of saying await for G to finish before we continue, all right? What we're doing here is we're gonna start G, but we're not necessarily going to await for it, okay? We're not going to await G's end, all right? We'll do that actually at the end of the function, okay? Because we wanna make sure that G finishes before we exit. What?
That's
Oh my God.
indentation.
Oh, okay. No, it says it's not a lot.
Inconsistent.
Oh, okay.
There you go.
Okay. So okay, yeah. So sorry, that is correct. So basically, what this is going to do now is we're going to create the task, and then we're not going to wait around. Okay, we're just going to. We're not necessarily going to wait for G to finish. So if I did this, actually, I'm going to do this. And I think this will better illustrate it.
Yeah.
Right? So I'll just, actually, I think this would be better. I just did this. And F is starting.
Mm-hmm.
And F is ending, right? So if we imagine what's going to happen now, here's what we expect. We're going to do async io.run f. Okay, so f is going to start. The f coroutine is going to start. Mm-hmm. We're going to print out f is starting. Then we're going to start G. So we're going to go into G. We're going to print G is starting. Okay. We're going to then hit this, await async io.sleep for 2 seconds. The computer is going to realize that, oh, okay, I have 2 seconds where I'm just doing nothing. So I'm not going to wait around. I'm going to come down here, and I have other things I can get along doing, right? So it's going to print F is ending, okay? And then before we're done F, we're going to wait for task to finish. In this case, task is G. So we're going to then wait for the full 2 seconds, and then it'll print G is ending. So what we expect is that pretty rapidly, we're going to see F is starting, G is starting, F is ending, and then like 2 seconds later, G is ending. All right, that's basically what we expect, and it is actually possible. Did you run it yet?
No,
you
no.
didn't. Okay, wait. So it is actually possible that this is going to take a certain amount of time. Okay, and so we might actually get F is ending before G is starting, but we can fix that if that happens. So let's just run it, just to warn you. Yeah. So we do get it before that. But you saw there how we saw F is starting, F is ending, G is starting, and then a little bit later, G is ending.
Yeah.
So that's basically what we expected. What actually happened there in that instance is that this took a little bit of time to happen, right? So F is ending actually hit before we got to G is starting. What we can do to just like show you what's actually like going on in a more realistic example is if we also awaited async IO dot sleep here, but we like slept for only half a second. So now we'll get the kind of result that we were thinking of before, right?
There we go.
Right, exactly. There we go. So now it's running at full efficiency and not waiting any longer than it has to.
Right. Instead of taking 2.5 seconds for this code to all run, it's able to do it all in 2 seconds.
Right. So if I'm just going to quickly code up a
Question.
Question.
Mine doesn't do it in the right order, it seems. Hold on, did I forget this? Let me try running this now. Yeah, it does start function F, end function F, start function G, end function G.
So did you add this sleep over here?
Oh, I didn't add that G2.
No, don't worry about G2.
No, don't worry about that yet. Don't worry about that. I'm just gonna show you like an example with what it looks like without using asynchronous programming.
I did add async IO sleep.
Did you say you're saying await, right?
Yeah, wait, async IO dot sleep.
Uh-huh.
Oh, but I didn't add a second one. That's probably why.
Yeah, it might have been printing out in the order I said before. So again, that's just because we're like running through it too fast, but that's okay. Like that was also a perfectly desirable result. So here in this case, if we call F2, so instead of async IO dot,
You just called it F.
Oh, oops, sorry. So if I call F2, right? So this is what it would be like if you just did not use asynchronous programming, right?
Right. So
F is starting, G is starting.
G has to end before F can end.
Yes, and also F took another half a second there as well to end, right?
Exactly.
So the whole thing took 2.5 seconds, right? Whereas the other thing,
you could actually time this, right? So start time equals time dot time, and then you could print out
time dot time.
Program took time dot time minus start time at seconds. Right? And so when I run this, you can see we roughly took 2.5 seconds.
Right, and if I go back to the other way of doing it.
You commented out the wrong one.
Oh, oops, sorry.
And this needs to be timed before it. So like that. If I run it, you can see 2 seconds. Right?
Right.
So does hopefully everyone kind of get a picture of what this is for now? Right? And so we can illustrate an example with more scale.
Yeah, question?
What is time dot time, out of curiosity?
Just the current time.
It's the current time, yeah.
So when we take the time after the after this all ran, and then subtract the start time from it, we get the difference in time.
Like, is it the time when the program started, I assume?
No, it's the number of seconds since I can like find it for you if you want, but it's like the number of seconds since like 1970 something.
Wow.
It's just it's a measure of seconds since like a given time. So it's basically the timer on your computer. Right.
Exactly.
The time on your computer is just a number. Okay.
It's not really important, but yeah.
Okay.
Okay, so that's asynchronous programming. That's the kind of idea behind it. It's to just eliminate downtime, and we can write code in this way to kind of not do multiple things at the same time, but just in the time where we're doing nothing, be more productive, right? That's what asynchronous programming is. That is the first advanced concept that we're teaching. Now we're going to switch gears kind of completely and talk about something different, unless there's any questions, which is going to be function decorators.
Yeah. Okay. So first things first, I want to say, if you were confused about asynchronous programming, stick around. I know we have to like finish before 5:15, but I don't. I can stick around and explain some things if they're confusing. But let's move on.
Okay, cool. So decorators. I'm going to quickly make a function here. We're just going to call it foo, okay? And what it's going to do is I'll take import math here, right? And we're going to make a list, and this is not important, okay? So we're just going to make a list here, and we're going to loop maybe a bunch of times, okay? And we're going to append math.square root of that number, and then we're not even going to return it. This is just going to be a completely useless function, okay? This function, okay, maybe we have this as part of our code, and we're not really sure how long this is going to take. Now, something we could do is do something like what we did before. So import time, just like what Alex did literally maybe a minute ago, right? And say start time equals time.time, right? And then we can call the function, and then we can say we can print out f string, and then program took, and then we can do the time.time again. So this will be the current time minus start time, right? And seconds. And this will time the program. So we'll be able to see how long it took, right?
All right. So if I run it,
Now,
I just want to show that this works.
Yeah.
So it says it
Right.
took 1.95 seconds. There you go.
right, there we go. So it took a while, but that's not really the important part. The important part is that we had to write out this code, which is not really like, you don't necessarily want to have to like put this into your code every single time, right?
Yeah.
You want
Imagine you're
to-
timing like a ton of functions.
Right. Yeah. And it's just like inconvenient, even if you're like, maybe you're like debugging a bunch of stuff, like maybe your program's running slower than you think it should, and you're like trying to figure out what part of it is really, you're trying to diagnose the problem kind of. And so you're like doing this with all of your functions. Now, of course, there's nothing necessarily wrong with this, but you might want to be able to do something a lot simpler. So the people who made Python thought, well, wouldn't it be nice, okay, if I could just, well, they didn't, I guess, think of this exact use case, but they thought that, okay, well, maybe someone wants to make a feature where I can just do something like this. I can be like timer, okay? And then I just put that on top of the function and it automatically times it or something like that. And I can just like call the function, and then like anytime I call the function, it'll just time it, okay? This is the idea behind decorators, okay? Not necessarily to time it, but to just modify functions or to kind of, do things with functions by adding these little tags on top.
Yeah.
They're called decorators. To add these little decorators on top of the function and have them behave slightly differently, okay? So we're going to go over how to create how to create decorators and how to use them. And we're going to use a timer decorator as an example, but there are many. So if you were watching the CCC, the programming, like I guess preparation talks that we were doing during February, you might remember dynamic programming was something that involved storing the inputs to a function so that if you ever saw them again, you just reuse them. And so there is actually a decorator in a library called cache, I think, where you can literally just say at cache, and it'll just add dynamic programming to your function literally without you having to do anything. Okay, so that's another example of a decorator. But we're going to make a timer as our example here.
Yeah, let's first make it using our existing knowledge, right? How we know to do it already, like with what we already know, without using this new feature of decorators. So we're going to create a new function, right? It's timer, and with the way we currently know it, right, for us to be able to time our function, right, we need to know what function we are timing. So we'll pass it in as a parameter, right? And then what we can do inside of this is actually call that function. So what I can then do, right, is I call timer, and then I pass in that foo function, right? And then that will be passed in as that func parameter, and we can call it, right? And that will work. And then what I can do is I can wrap that function around with some of my own custom functionality, right? So in this case, I wanted to time it, right? So sorry for typing this out for like the millionth time, but I didn't mean to put the F there. I meant to put it here.
Oh, okay.
Start time minus time dot time, and like that. All right.
Okay. So
And-
that's nicer, right? We can just call timer now on the function, okay? And this will do the same thing. Why did it take
I
a negative
subtracted
two?
the wrong order.
Oh, right, yeah.
Silly me. Whatever. Negative.
So the function went back in time and like gave the answers before you even started.
Yeah. There you go. So that works great, right?
Mhm.
But what if you wanted it so that the user doesn't have to wrap the function call with another function?
Right. Or what if we like, what if we wanted to, the idea is that like, maybe in this, we want to build towards what the idea of a decorator actually is. And this is not exactly it. So I guess the next step is we want to be able to have another function. So we want to be able to kind of take this function timer, right, and change it from a function which just gets called, right, to a function which returns a modified version of the original function which has the desired properties. Okay, so what I would like to be able to do is say timed foo equals timer of foo, okay, and then call timed foo, okay. This is kind of what I would like to be able to do. And then I can call foo separately as well. If I wanted to do that, right, what I would do is inside of timer, I would create a new function, okay, and we'll just call it f, right? And I would put all of this code inside of f, right? So we're creating a function inside the function. We're still allowed to use this parameter. It's totally fine because we are in the timer function, right? And then what I would do is I would return f, okay? And now what's happening is when we say timer of foo, okay, it's going to take foo, it's going to pass it in here, and it's going to return a new function which times foo. Okay, and then we're going to return it down here, right? And then we can call that. So this should also work the same way.
Right. So again, it times our function, says it took that much time.
Right. Does anyone have any questions about the current format? I know it's not something you're used to seeing, although we're not introducing any new concepts yet. We're just kind of introducing some patterns, which maybe you think are kind of weird, like what you can make functions inside of functions. Yeah, you can. And you can also pass functions into functions, and you can also call those like within the functions. Everything is totally allowed. You just might not have known you were allowed, but we're not really introducing any new concepts here, right? But is anyone confused about this?
Yeah, don't be afraid to ask in the chat or raise your hand or turn on your mic.
Okay.
Just to clarify, this function here is basically just getting the time and then printing blank function took blank time in seconds. Well, what's return f about?
Well, f is the function there, right? So we have this timer function, and we create a new function. Notice the name is f, right? So we create a new function, which is this, and then we return that new function that we created.
I see. So you make a function within the function to count the time and stuff.
Right. So maybe it helps if I rename this to like wrapper, right?
Yeah.
What we're doing, right, is when we pass foo into timer, it's defining at runtime a brand new function for us. That function is a specific version of this wrapper function, which has the start time, calls that specific function, and then prints out the time that function took, right? We can create as many of these as we want for different kinds of functions. It's not specific to timing foo. We could have, another function, and then this one takes, I don't know, math.log of I, right? And then we could time that one as well, right?
Right.
And now what this timer function has done is it's defined 2 new functions for us, right? It's creating functions on the spot for us with this right here.
Right. And now we've actually done everything we need to possibly do to do decorators. So what I can do now is I can get rid of this, okay? And all I have to do is type @timer over top. And what that'll do is it'll take foo and it will transform it into the timed version of itself. So it'll take foo basically, and it will then apply this wrapper to it and then replace the function with the wrapper. So now when I call foo, I don't have to do anything. It'll automatically time itself now. Right. So notice how I just called foo. If I remove the @timer, it'll just go on. It will do nothing because the function doesn't print anything. Right? It'll just take a couple seconds and then stop running. Right.
There you go.
But that's what a function decorator is. So anytime, now normally you're not going to be making decorators, and I know we were going to go into function arguments. I'm just thinking about the time right now, and
Okay.
I'm thinking it might not be best to do it. If you want to know about how you would maybe make a decorator yourself where the functions are allowed to have arguments, you can maybe say after, and if you have that specific question, you can ask Alex about it. Typically, it's rare for you to define your own decorators. I mean, you can certainly do it. It's a good thing to be able to do. But more often than not, you're just going to be using decorators, which are associated with APIs. So like with the Discord, again, there are a lot of wrappers and a lot of decorators, that the Discord API has like already. So I just want you to not be confused. If you see something like this, right? Just know, don't get confused by this. Say, what the heck is going on? It's a decorator. It's just taking the function and modifying it in a way, in a particular way. So I think with Discord, there's like a Discord.event or something like that. You can say that.
So for decorators like that, actually, right? They don't necessarily have to actually wrap that function in some new kind of behavior. It's an option, right? And that's what you most
Right.
commonly see them used for, right? But in the case of like an event, what it would do is it would register that as one of those like Discord events for you. So it can just take in that function and then return that function back. Like we could just not define anything in here, right? And return func, and then maybe do something with that function before it. You know what I mean? Like I could add it, say I had like a list of functions to call on message, right? It's a long name, but just to show you, right? And then I could add that function, right? And then whenever I have a message, I could call every single function in that list, right? And then I return that function, we're all good, right? And that way, instead of the user having to manually add it to that list, them just adding that little tag, that decorator, right, will create that functionality for them. So they're very flexible. It's a really useful feature. And so we're going to see that a lot in that Discord library. I'm going to undo everything that we did.
Yeah. Right. Okay. So anyway, cool. And I'll just make this timer again. Yeah. Timer.
Yep.
Cool. All right. And so that is the second advanced topic we wanted to talk about. And then the third one and we have 20 minutes to talk about it, is inheritance. So this one doesn't have to do with functions. Instead, it has to do with classes. And classes are, and I guess notorious for being one of the more advanced things for some reason, even though they're not really that complicated. And inheritance is probably going to be the easiest thing that we talked about all day. So, you guys?
I'm good. Hello.
Okay, sorry. Hello. Okay. Inheritance deals with classes.
Mm-hmm.
Say, for example, I am making a program to keep track of staff, and I work for the Peel District School Board. Okay? Maybe what I do is I have a class, right, of teachers. Okay? So, well, not teachers. It would be a teacher class, and then I could have a list of teacher objects, right? And so, maybe the teacher, right, has, so self, if we define the init function, right? Maybe the teacher has a name, teacher has a, what was the other thing?
Subject.
An age, and yes, and a teacher has a subject. Teach, like this, right? And then we can in here say something. Not like that. Why did it do that? Okay. Self.age equals age, and then self.subject equals subject. And what can a teacher do? Well, a teacher can.
It was like greet or something.
Yeah, I guess. Yeah, greet. So this will just be their just like to their fellow employees. So we'll say, hello employee. Okay. But maybe they can also teach something, right? Because they're a teacher. Okay, and now my analogy of actually working for the Peel District School Board and making this class is kind of breaking down because that's not how this would work. But so it's say they're teaching and they say, what's an interesting thing to teach? So sine is the ratio between the opposite side and hypotenuse of a right triangle. Okay. We're just going to print this, okay? And they're going to say that this is the thing that they are they're teaching, okay? So that's a teacher, but the teachers are not the only people that work for Peel, okay? There is also, janitors in the school. Right?
Class.
Did I say deaf?
Yeah.
Sorry. And, they're going to have a lot of the same functionality. So I can just actually kind of copy paste this, right? Because they're going to also have a name and age. Oh, they're not going to have a subject, though, so I can get rid of that. And, maybe instead of subject, they have a well, maybe they just don't have anything, right? They have a name and an age, and maybe they have some other information, but maybe the teachers also have that. I don't know. And another thing they can do is maybe they can clean, and this is just going to be parents cleaning, right?
Oh,
okay,
and janitors are also people. They should be able to greet as well, right? Let's do some copy pasting.
Right, exactly. So they can also greet. Okay. Now, this is all well and good, but you can imagine there are certain cases, right, where you have this sort of situation where you've got two classes which are different, right? They're not the exact same thing, right? Because teachers teach, janitors can clean, teachers have a subject, janitors don't, But there are still, despite their differences, right, you need the separate classes, right, because of the differences, but there are enough similarities to kind of warrant a double take to be like, there's a lot of duplicate code here. I literally have this exact same greet function twice. That should be a red flag anytime you're coding, because it means that you're duplicating code, which is something we generally don't want to do. Sorry, question.
What does pass mean in the case of a class?
It means the exact same thing that it means in the case of a function. Pass just means
Get your
it just means you're just not doing anything, right? So
okay.
The reason is because otherwise Python expects it expects something inside, right? So if it's missing, it thinks there's an error.
Yeah. Okay, so we have this idea that we want to kind of maybe make these into one class, but we also don't really want to do that. The key here is to use the concept of inheritance, where we're going to create a parent class, okay? And then both of these teacher and janitor classes are going to inherit, meaning they're going to take properties of the parent class, and then they're going to be able to add their own properties on top of that. Okay, so let's actually show you what I mean. So what we'll do is we'll make a parent class called employee, okay? Because this is just going to be a general employee, okay? And we'll actually take the init function from, well, we'll actually take it from janitor, right?
Yeah.
That's probably better, right? So we'll take it from janitor. And here, so an employee, every employee has a name and an age. So notice how a teacher has a name and an age and a janitor has a name and an age, and we have to initialize both of those in both cases, okay? The teacher has an extra thing, but that's something else, right? And then both of them can also greet. So I don't know why I typed F when I'm just going to copy paste the function. But anyway, so there we go. They can both also greet. Now, they can't both clean and they both can't teach, right? Not all employees can greet or can teach or clean, right? So we're not going to put that into the parent class. Now what we can do is right next to the name of the class, we can open up some parentheses, right? And type employee. And that will indicate that employee is a parent to the class that we're making. So employee, or so we want to inherit from employee is how we say that. So same thing here. We want to inherit from employee, right? And now we can actually get rid of greet. And what's going to happen is that they're going to, both of these classes are going to know already that they need that they're going to have a greet function by default, just because they're inheriting that from the employee
Yeah,
class.
so let's actually see that in action, right? I'm going to create a t equals teacher. And so what should we do?
Teacher, right, name, age. So we're going to do Mr. Kwan.
Fun, okay.
Kwan, right? And the age is going to be 65, and
He also has a subject. Physics.
Oh yeah, he also has a subject. 38. Oh hey, okay. Oh sorry, 38. Okay, I couldn't remember off the top of my head. We'll change that. 38. Sorry, my mistake. I made a typo. 638. No, not quite. 38. Okay. Sorry, Mr. Kwan. I didn't realize you were paying attention there. Sorry. Okay. Physics. Yes. And then we'll have Jay be a janitor. I unfortunately don't know the names of the janitors at our school. But
so what was the name we did earlier? I don't even remember.
I think we did Carl.
Yeah, Carl. All right.
Carl.
All right. Carl is let's just do 32. There.
Yeah, and we're gonna.
32 is a nice power of 2.
Right, exactly. And we don't need to pass in the subject. So, and then what we can do is we can. Okay, yeah. Sorry, go ahead. You can do.
Yeah.
You can
So
greet
both should now be able to greet, right? But, right, we shouldn't be able to do, for example, janitor can't teach, right? And so you're gonna see. Okay, well, maybe it's not gonna show in my editor, but it is gonna tell me here, right? So hello fellow employee, that's these greet functions, they're working, but then janitor doesn't have a teach function. So even though inside of the class janitor, inside of the teacher class, right, we don't write this greet function because we're inheriting from employee, right? It's taking this greet from it, right?
Mm-hmm, right. And just to illustrate, sorry, don't delete it. Just to illustrate, the teacher still has just the teach ability because that's actually in the class, right? Mm-hmm. So if we did t.teach, that would work. Yep.
Question for creating classes that pull from other classes, like in this case.
Yep.
Does the said classes point from always have to be above it, or does the ordering not matter?
I think the ordering doesn't matter.
Yeah, I believe the ordering doesn't matter.
Yeah. You just don't want a cyclic thing where like one class like inherits from another class which also inherits from it. Like that's not good. But
Right, like if you have A which inherits from B and then B inherits from A, then that's not good. Or if you have
no.
A that inherits from B and B inherits from C and C inherits from A, like that's not good.
But you can have multiple layers of inheritance. So you could also, I could make a math teacher class and a geography teacher class, which both inherit from teacher. I could do that, but as long as I don't have the cyclic dependency. Okay, so there is a little bit more to talk about. First of all, you'll notice that the employees init function is the exact same as the janitor's init function, which means we can say bye-bye to that, right? Okay. So we actually don't even need to define the janitor's init function. And look at how clean the janitor, I didn't mean to make the fun, but look at how clean the janitor class is at this point, right? Now, the teacher's init function is also very similar. It's not quite the same though. What we would like to be able to do is call employees init kind of in teachers init and then do the extra step of adding the subject on top of that. So what we'll do is we'll still define an init, right? And we'll have a name, an age, and a subject. And it's worth noting that anytime you have an init and then the parent class also has an init, this will just overwrite whatever the parent class did, right? So what I can do is I can get rid of this, okay? And I can call my parent's class's init function. So the way that I do that is I say super. And now super is going to refer to employee because that is the super of teacher. That's the parent class, okay? And then what I'll do is I'll call init, okay? And init is just the parent's init. And then I'll pass in the name and the age. And then I will also add on the subject. So what this is going to do is we're going to take in a name, take in an age, right? Take in a subject, and then we'll pass in name and age to the employees init. So that's going to define self.name equals name and self.age equals age. And then we'll, on top of that, also do self.subject equals subject. And so now we've significantly shrunk this code, right? You can imagine if you had a lot more classes also. Like, for example, if you're coding chess, you might have a parent class, which is a piece class, and then for every single piece, you might have a difference, like pawn, knight, rook, etc., bishop, queen, king. You might have a separate class which inherits from piece. Okay. I think that's it.
Yeah, so this all should work, and it'll still do the same thing.
Yep.
Right. Awesome. I mean, this is a pretty good time to be done with this. So,
yeah. There was definitely a lot that was taught. 3 pretty much completely separate topics were taught. So we had asynchronous programming, which is not giving the computer any downtime, figuring out how to program, how to run code while, requests are being made. We had decorators, which are ways to kind of, modify existing functions in desirable ways, or to kind of take that function and, pass it in or give it to, another function. So in the case of Discord, for example, and inheritance, which involves taking classes, okay, and creating subclasses, which all have shared properties, but are all different in their own way. And so these are 3 pretty advanced topics, but you're going to see them all come together next week, hopefully in a beautiful symphony. So yeah.
Yeah. All right. Well, in that case, does anyone have any questions about either 3 or felt confused about one of the 3? Go for it.
2 things, though they're kind of unrelated.
Okay.
One, all the files that you use here are going to be posted on the Google Classroom, yes?
Yes. I'll also post a recording of today if you want to refer back to it.
Okay, thanks. And 2, what is multi-threading?
So basically the short answer is that it's running 2 pieces of code simultaneously. Okay, we're not going to worry about that because we didn't teach that today. It's different than asynchronous programming. We might do that for a future coding challenge. I'm thinking about doing that for another future.
Okay, then.
Yeah, but basically what it lets you do is it essentially runs 2 separate almost programs at the same time. right? And then they can communicate with each other, right? So
Right.
if I was doing some crazy calculations, but then I also needed my user interface to be super responsive, I would have those calculations going on a separate thread so that they wouldn't bring down the main process, if that makes sense, right? Because I'd want that user interface to still feel super responsive, right? But that's not really the priority here, right? What we're doing with asynchronous programming is we're just basically saving ourselves in a really easy and straightforward way from things like delays due to internet speed, right? We basically don't waste our time with the computer. All right. Hopefully that answers your question, yeah? Are there any
Yeah,
other
it does.
questions?
Thank you.
Yeah. Yeah. Does anyone else have any questions or feel confused about it? Feedback's always good, so if you found like one of these three confusing or all of it confusing, like if you didn't get anything, also tell us because we don't want to assume then that you guys understand this all, right? And if anything needs to be like re-explained, please tell me. And don't be shy either, because if you didn't get it, chances are someone else didn't get it. So it's more of me to just
Right.
double check.
I would be surprised if, like, this is some pretty hard stuff to understand. This is like at the upper echelon of like, this is not like necessarily like the hardest thing in coding, but this is probably the hardest thing in terms of like, this is the most advanced concept you'll ever run into in terms of like syntax, pretty much in Python. So in terms of like Python programming syntax, this is basically it as the most complicated stuff you're going to find.
Yeah.
Okay.
Okay. Well,
In
yeah.
that case, I'm gonna go.
All right.
'Cause I gotta head to work, so I'll see you guys, and yeah, hope to see you next week. It'll be more exciting. We're going to actually get a final product going for the
Yeah.
Discord bot.
All right.
Oh wait, I just remembered something. Can I ask a question about the Python about the Discord code?
Yeah, for sure. Just stick around, honestly.
Okay.
Yeah. So for everyone, I hope you guys all have a good week. If you have any questions or you remember some kind of question that you had from earlier on, please email me or Max. Right. We
Right.
don't bite. Or if you have a question right now and it's a little more like personal, feel free to stick around. That's also an option, right? If you guys are feeling confident and are ready for next week's Discord bot, make sure to be there next week. And I hope you all have a good week. Hopefully it's not too busy. Yeah. And I can't wait to see you guys next week. So goodbye, everyone.
All right. Bye.
So yeah, I'll be leaving right now as well.
All
Have a
right.
good
See you,
day.
Sahil. Goodbye.